we need to show that the m plus nth term of an AP is 0 whenever m times the mth term is equals to n times the nth term. So let's begin. We will first consider the first term. Let the first term be f lowercase a and the common difference be represented by lowercase d. Then it's given here that m times the mth term, that means a times am, is equals to n times the nth term. Right. So we have m multiplied to the mth term is represented by the first term plus m minus 1 times the common difference d. So this will be equals to n times the nth term. So nth term is first term plus n minus 1 times the common difference d. So we'll multiply m with each of the terms within the parentheses. So we have m times a plus we have m times m minus 1. So that's m squared minus m times d. So that's equals to n times a plus n squared minus n times d. So we'll transpose all the two terms from the right hand side to the left hand side. So where we have ma plus ma minus n times a plus m squared minus m times d minus n squared minus n times d equals to 0. If we take a as the common factor, we have m minus n plus we're going to take d as the common factor. So here we have m squared minus m minus n squared plus n. So this will be equals to 0. Right. This will further simplification is going to give us a times m minus n plus d. So here what we'll do, we'll combine this first term and the second term. So we have m squared minus n squared, and we'll combine the second and the third term, fourth term. So if we take negative as the common factor, we have negative of m minus n, which is equals to 0. We have a times m minus n plus d times, now m squared minus n squared, that's an identity, which can be also expressed as the product of m minus n times m plus n minus m minus n, and this is equals to 0. So we'll factor out m minus n here. So here we have a times m minus n plus d times m minus n, all multiplied to m plus n minus 1. So this is equals to 0. Now factor it out m minus n from the two terms. We have m minus n. So this is multiplied to a plus d times m plus n minus 1, whole thing equals to 0. So this would mean that either m minus n equals to 0 or a plus m plus n minus 1 times the common difference d equals to 0. So this gives us m equals to n, or so here this is actually nothing but the m plus nth term. So this is equals to 0, and this is what we have to show, that whenever m times the mth term is equals to n times the nth term, this would simply mean that our m plus nth term that's equals to 0.